Hello and welcome to it. This is Learn Extra Live on Spring School. Otherwise, it is also Heritage Day. So I just want to say this in my own language. Mnage kamalam ningusbongiseni Abraham Gentu udlamenu zizu chechengwane dumagano zandla. I welcome you all. Ngithi sanibonani dumelang absheni. Yikai bakayena. This is your show Learn Extra. I'm joined by Dave. How are you, Dave?
I'm fine, Abraham.
Well, you look surprised. What's wrong?
No, I'm learning all the languages from you, man.
Okay, but you can speak Sawubona.
Nah, Sawubona.
Unjani?
Nina ninjani.
Aspili not. You know what? I'm so proud of you. I'm so proud of you. Keep it like that. Otherwise, how's your holiday?
I think I must add in an Indian word to namaste. It's also a greeting.
It's also a greeting, yes. Yeah. I just don't know how to reply to that. It was going to be better if I was the one saying that. Yeah. But otherwise, how's your heritage
Fine,
and what are we doing?
I'm just excited to share knowledge with the learners, and I think that's part of Heritage Day.
Knowledge is power. Knowledge is power.
And maybe learn something from them also.
You are. Yeah. You are. Trust me. What are we doing?
Well, today we're looking at, hello learners. I hope you're ready for another live show of geography. Today we'll be looking at geomorphology, also known as fluvial processes and landforms. And we'll be looking at some past papers, the supplementary paper itself, and the various questions and the techniques that we're going to look at down there. I just want to tell the learners, and I hope learners, that you are actually balancing your time between your different subjects, which is very important. You know, not just your maths and science. So plan your timetable carefully. For instance, on Mondays, you can do science and geography. On Tuesdays, life science and geography. On Wednesdays, maths and geography. Am I doing geography too much?
Yeah.
But I think they get the idea. Please balance your time all the time. Okay.
I like that advisement. It is that every time you should always have a study timetable and follow it. Don't just draw it up and put it on the wall or on the fridge. Follow it. It's very much important. Let's get straight to it and let me tell the mindsetters what they need to know. To get in touch with us, you need to follow us on Twitter at LearnExtra, and secondly, like our Facebook page, which is having about 53,990 something learners. I'll be telling you more. We're close to 54,000, so get liking. The page is facebook.com/LearnExtra. Otherwise, you can also get your notes for the show for free on learnextra.co.za/Spring School, all one word. But we have an exciting competition, and I know that a lot of you know about it, have seen it on Facebook, but let me tell you about it. You can win an awesome Learn Extra hamper, an awesome hamper from Learn Extra, by simply tagging yourself on the post that we have. We have a block of numbers from 0 to 9. So you choose a lucky number and tag yourself on your favorite number, or share the post and then write on that share your favorite number. For instance, Dave, what's your favorite number or your lucky number?
I'm going to give it to you. You won't take a lotto on it, eh? Because that's my number.
Yeah, what is it?
My number is 36.
Between 0 and 9.
Oh, 0, 9, 6.
6?
Yes.
Why 6?
I was born on the 6th.
You were born on the 6th. Okay, I was born on the 8th. I'll take 8. Is it fine?
Yes.
So my lucky number is 8. All you need to do is to tag yourself on that lucky number, your own, not mine, and also share on your wall and then write. You could win an awesome Learn Extra hamper. But lastly, you can join our geography group, which is Mindset Geography, which has also the notes, and you can also get other students who are doing the same subject, which is geography, helping you and you help them. Otherwise, masingene go that.
You're handing over to me for sure now.
Yes, sir.
Is your section finished?
Yes.
Abraham, you speak so well.
Thank you.
I'm sure you must have been doing geography. Eh? And I think map work was your favorite section, because I can see you got direction. Now that's a good one.
That's a good one.
Okay, learners, let's go on. The fluvial processes and landforms, structural landforms, or also geomorphology. Before I go on to the section, many learners see this as a rote learning, parrot fashion section where they just take the notes and just study them and sort of try to regurgitate them in the exams. Now, learners, this section is different from that. Many of us, what do? We take the past paper and the memo and we sit with it together and try to look at the memo with the questions and say we're ready. I'm going to show you today that this section actually you can use the source material and get so much of the answers. So when you're studying this section also, it's important to look at the source material, to look at the visuals that you have and make sense of your questions in order to get the answers. And the section becomes so much easier. So we'll be looking at those various techniques. I know you've got the memo at home, but we'll be looking at techniques of how we use the source and how we get to the answers. Abraham, you're going to learn a lot.
Trust
And
me,
maybe
I'm
you're going to use it
open-minded.
at your
I'm ready to
university. Eh?
learn.
So that's what we're going to look at down here. All right, guys, let's get started. I'm going to take the first source. This is actually the supplementary paper 2013. And I'm going to take the first source that was used here. Okay? It says, refer to figure 1. And I must try and get my pen here. It says, refer to figure 1, which shows a drainage basin. Already, the examiner is giving you some direction towards what the questions are going to deal with. Immediately in your mind, the drainage basin concept should be playing around. Okay? An area drained by a river and its tributaries. Okay? A runoff system. And complete the statements below. Okay, and it's very quick for some of you that rote learn, is to just go into the questions and try and answer them. But let's look at this diagram. And I want to do this question together. I normally tell learners, interpret the diagram before you answer the question, and the rules still stick with that, because any source given to you has so many answers in them. So learners, but in this case, what I'm going to do now is I'm going to take the question and the diagram and show you the relevance of the resource. Okay? Now, it says a process, the first question, and of course you have to find the terminology for it. It says the process where water vapor changes into water. All right? The process, let me get back here. It's the process where water vapor changes into, sorry guys, I think my technology is messing up a bit there. When water changes into water vapor. Now, many of us know the answers, but if you want to rectify whether we got the right answer, what do we do? Look at the word A down here. All right? And A shows you this point. Water is rising. And when water rises, it changes into water vapor. And of course, we get the concept of water moving up, evaporation. All right? But if you want to confirm, can you see water moving up? So that little resource gave us an idea of what the answer, and it confirms it. So here, when water changes to water vapor, it's evaporation. I'm impressed with my writing, Abraham. Normally
nice.
I've got terrible writing. Eh? I think the learners know that by now. Okay, let's look at the next one. A place where two or more streams actually meet. A place where two or more streams meet, and it's giving us a little clue on the resource that it's B in a drainage basin. Let's get back to the resource. Where two or more streams meet. Okay? So when we visualize it, the answer comes easier. So let's look at this. Obviously, where two or more streams meet is known as a confluence. Okay? All right? An area where the river originates. Many of you know the answer already, but let's look at the diagram. It shows you C. The river originates. And it's high up in the mountain there. Obviously, it is the source. Okay? All along the way here, learners, you actually see that the diagram is assisting you. All right? Let's look at the next one. The process whereby water seeps into the ground. And once again, learners, we have a visual as it's seeping into the ground. All right? And we know the concept will be infiltration. By the way, learners, I've been practicing my writing. I think it's definitely improving for this show. Okay? Last one, a high-lying area that separates two streams in the same drainage basin. Very important. The visual will show you here also. It's one stream. Because of this question, learners, many people make a mistake between a watershed, all right, and an interfluve. Now, this is one stream, okay? Sorry, one stream or two streams of the same river system. It's not two different river systems. So it's important, this picture showed me already, and also it'll assist me from not making a mistake. Oh yes, it's one little river system here, all right? And there's two streams of the same river system. So it can't be a watershed, it's a interfluve, all right? So a high-lying area separating two streams of the same river system is an interfluve, okay? So quite a bit of answers. The visual helped us, and we were able to get quite a few answers even by just looking at this. So it's important. Again, fluvial processes, landforms, geomorphology is not just rote learning. You can pick up so much. And I'm going to show you on the next diagram of how much information we could actually pick up down here. All right? Let's go to the next one. It says, refer to figure 2, which illustrates a drainage basin. Again, the examiner actually draws your attention to the main concept being used in this question. And of course, that is your drainage basin. And immediately, if you got your visuals and you've been using visuals when you were studying, right, not just taking the questions and the memo and just trying to know this question and that's the memo, but working out that memo yourself and using resources, you will notice that you'll be able to do this much more easier by visualizing. Drainage basin. Oh yes, an area drained by a river and its tributaries. You can visualize the water coming in. I always use the sink in the kitchen. To explain, I know, to my daughters also what a drainage basin is, the area and the water getting into that little hole. So I'm visualizing, and it's making it easier for me to understand. So let's get going. What do I see on this? Yes, I see my drainage basin. There it is down here. All right. I also see how the water is draining into the river system and coming down. All right, let me go back. I think my technology today is messing me around. All right.
It's on holiday.
It's on holiday, eh? I think so. But not bad for my age, right?
No.
So it's moving in. I can see this whole picture unfolding in front of me, the drainage basin itself. All right? So I can see activities happening here. I can also see what's giving me water in that drainage basin? The rain, the snow. I can see that coming into the drainage basin, all right? And I can see other things actually happening here due to human activity. I can see deforestation happening, where vegetation is being removed. And all of a sudden I start to think, okay, vegetation being removed. Whoa, there's going to be more runoff, less infiltration. Okay, more erosion. These factors tend to come into my mind. I see industries here, and industries again, I see concrete surfaces, roads. I see less infiltration. I think industries, I think pollution into the rivers. I see houses. I see more construction. I see more urban development. All right? Not necessarily. Houses could be rural, but I see more concrete surfaces. I see cultivation. I see farming. I see removal of natural vegetation. All right? And planting of our crops that man actually needs. So I see so much into this, and I build my picture. Already I know if I close my eyes, the examiner is going to look at working out what is a drainage basin, looking at inputs into the drainage basin. Also, I'm already started to picture, I can work out the questions already. Hey, I could see the impact of man on the drainage basin, and I've worked out so much already. And I've already set now for the questions. But learners, don't jump to the questions first. Use your visuals, use that. The examiners have put it there for a purpose, to assist you in terms of getting the answers for the questions that follow. So let's look at the questions then. 2.1, there we are. Define the term drainage basin. And if you look right on top, there it is down here. The word drainage basin. So it leads you on all the time. So of course, we know already, because we've used our resources properly, we don't even have to waste time. It just comes out now. All right? And the drainage basin is an area drained by a river and its tributaries. All right? As shown there, an area drained by a river and its tributaries. Let me get back to my pen. All right, and its tributaries. All right, your full 2 marks. You've worked that answer already. Here we are again, and we're using the source again. Name one source of water for a drainage basin. Learners, I know, and when we had to revisit this memo, there is one word here that made it open. A drainage basin. All right? Name one source of water for a drainage basin. The word for this drainage basin it should have mentioned. Now, learners, a little tip here. If there's information on the source, use that information first. Although it says a drainage basin, you could use various other answers, but stick to the resource first and see what's in there. And if we move up, it's very clear. We can see snow, we can see rain, all right, as coming through. Okay? So that is your inputs, and you should focus on the source first. Obviously, it's at a drainage basin, and maybe other sources could be accepted, but it's safer to find it on the source first. Okay? And if you look at the answer here, I'm trying to get this going again. And it's rain, snow, and obviously base flow. Because if you look at your diagram again, water seeps in and it flows as base flow. But the main contributors is rain and snow, which allows for base flow for it to soak underground and flow. All right, let's look at the next one.
Right, Dave. I think it's time for a break. Don't you think?
You think so, eh?
I think
but I'm
so.
enjoying this, man.
I know. I know.
Let me go on, man.
I know. Well,
Okay.
you go
I think
on
the
after
learners
the
need a
break.
break because I speak too much.
Well, I'm
Okay,
speaking
man.
on behalf of them. So if they call it, let's say it, whatever they need, they must get it. Otherwise, man sisters, we've just hit 44,000. Thanks to you, 44,001. So if 1 is your digit, your lucky number, you are standing a good chance, but that can change at any time. Otherwise, for now, don't move. Yamavengeren. We'll see you after this. Welcome back, Mindsetters. Now, on the page, we're seeing some Mindsetters who are enjoying the show, such as KB saying, you know what, this is the best teacher to have when it comes to geography. Big ups to you, Mr. Dave. That's a nice comment.
And did you tell him, Abraham, that it was you that wanted the break? It's not them.
Yeah. Well, it was me, Mindsetters, me and my director, of course. But otherwise, I hope, Mindsetters, you are getting to the whole idea of this exam revision. And if you're stuck, make sure that you make sure that you hit us on Facebook, guys, and join the group. I urge you, all you geography students. It is called Mindset Geography. That's it.
You really like it, eh? Abraham, I think you have a question for me, but what I'd like to do, learners, before Abraham gives me the question is, we actually stopped halfway with this question here. I'd like to finish off with question 2 first. Abraham, then you can just pose me your question, and I could just help the one learner that was,
No problem, sir.
concerned about a section. So we actually stopped, okay, looking at the resource, and again, I just want to emphasize how we picked up the answer. Fantastic. From there, let's go on. Some drainage patterns, let's look at this question, and I hope my pen is working. All right, some drainage patterns have a high density. Now, already the examiner has given you a clue, okay, about high density. He won't just put that in there. He's expecting an answer like this. All right, now watch this. How does climate influence the stream density of rivers that flow along the east coast of South Africa? Because this can be a vague question, isn't it? Because sometimes you have learned, learners, that an area that doesn't have much vegetation will actually cause more erosion and have more stream channels. Okay? All right, so it can be confusing. Sometimes not necessarily have to be a very moist area, but with no vegetation, and you get a certain amount of rainfall, creates channels. But here the examiner has directed you. He says some drainage patterns have a high density, so it's given you a little clue about the east section of South Africa. And you know, what sort of rainfall do you have there? Lots of rainfall. And if there's lots of rainfall, you understand, there will be more channels being cut through because there'll be more rejuvenation, energy of the river cutting through channels, etc. So it's going to go on a higher density because the more stream channels there are, the higher density it is. Also, learners, notice how we taking concepts along the fluvial processes, landforms, and geomorphology. We're taking concepts from other places and putting them in here. Here we're talking about drainage density. So you don't just learn your sections in compartments. Okay? Link them up because they could come in from a different section to this section to that section. Okay, so this is straightforward. Now, as it mentioned, obviously it'll be high density. All right, the East Coast experiences higher rainfall, therefore higher rainfall, and I'm getting my pen again, which I'm always forgetting, higher rainfall, therefore rivers that flow in this area, okay, will have a higher stream density, okay? Notice the examiner also put in about the bird of South Africa. It's steeper slopes. So the emphasis here also is on rejuvenation. Steeper slopes, more energy, greater amount of water, more energy, therefore it will create higher density. All right? Now, learners, it says, give 3 reasons. 3 reasons, and I'm getting back to my pen again. 3 reasons why drainage basins are useful to people. Obviously, this is a more straightforward question. You identified the concept and you applied the concept of drainage basin. Drainage basin is an area which actually highlight an area from which the river and its tributaries gain its water or drained by a river and tributaries. So you're basically dealing with water, your concept. And remember, over the shows we said, know your concept, know how to apply your concept, and apply your concept. So if I know this concept and I know the application of it already, I know we're accumulating water. And water is a valuable resource. And immediately many things should come to your mind. Okay? 3 reasons for why drainage basin. Domestic use. What else? Industrials. Industries need it. What else we need a lot of water on? Yes, agriculture and farming. Okay. Water can be fun also, Abraham. can be a lot of fun, eh? When we're skiing and things. Unfortunately, not so much fun for me. I can't swim. I don't tell
you're
anybody.
not adventurous.
All right, yes, man. I'm adventurous, but I can't swim. All right, but there's so much recreation, farming, for industries. All right, let's look at some of the answers here. Provide water for domestic use. And let me get my pen again. All right. And I'm always flopping up here, but we got it back again. And make sure my pen is on. Provide water for domestic use. Provide water for agriculture and irrigation. Rivers can be used for recreational use. Water transport, maybe not so much in our country in terms of our rivers. They actually don't have the same depth in places. They vary with rainfall. But it can be used. It didn't say South Africa. Generation of hydroelectric power, source of food, when commercial fishing is done, industrial activities. So there's quite a few. And in fact, we could set a nice 12-mark question on this. But where is all this? Not just straight from a textbook, but it's taking your concept of drainage basins and applying it also to the notes you've learned and real life situations which you see on a daily basis. Okay, let's look at the next question. 2.5. I want to also point something out here also, guys, but let me just go through the question first. Many humans, there goes my pen again, many human activities are destroying our drainage basins. We've already seen our source, learners, where it showed us a few activities, eh? Write a paragraph, you know this, and I'm sure you must be sick of this because every time your teachers talk about it, I know my learners, and they go after me and they say, please make an abbreviation for this. Everything is 12 lines. Giving suggestions on how we can take better care of our drainage basins. Once again, learners, don't just read the first part and immediately see the 12 lines. Why I'm saying this, we find this year in and year out that learners read the statement and then answer. Okay? It talks about human activities destroying our drainage basins. Okay? And if you stick with that, you'll talk about the destruction. But if you read carefully, it says, write a paragraph of approximately 12 lines giving suggestions on how we can take better care of our drainage basins. So it talks about looking after our drainage basins, putting in strategies that will assist us in terms of keeping our drainage basins in a more healthier state. So it's important that we look at that. Now, let's go up again. Let's use, I know, strategies, but there's answers given to you here, learners. All right? There's answers given to you here. Like deforestation, industries, cultivation. It's on the resource, on the diagram. So we can use these little ones. Oh, deforestation. What did I learn in class? Yes, it's removal of vegetation. It's causing problems. What was the solution that I picked up on that? So it's guiding you. The resource is guiding you. Yes, it's about afforestation. Planting trees that will cut down on the erosion, that will allow more infiltration. Yes, that could be a solution. Let me look at this. Industry. What does it do? Okay, it does remove vegetation. Okay, it does cause more runoff, less infiltration. Okay, also there's a pollution factor here. What was the solutions I learned? Yes, maybe also create laws, rules and regulations that sort of create penalties or fine these people for over polluting, because if you pollute our rivers, we've got a problem. Let's look at this. Cultivation. Yes, I learned where natural vegetation is being removed and what is being planted is our crops. Okay? And sometimes we get a lot of subsistence farming, or we don't use proper methods of farming. We don't do sustainable farming where we make our soils last over a long period of time. We conserve our soils. Yes, I think that's one of the solutions where we actually try and conserve and do sustainable farming. Learners, can you see what I'm doing here? I'm finding so many answers here. I'm using the source and finding the answers. Let's get down there and look at the answers. Okay? And I want to show you something else down here. I'm sure it was this question. Right. Now, it speaks about monitor and manage river systems, or rivers and the catchment area. Let me get my pen going. What you picked up as one of them, we can monitor and manage our catchment areas. Okay? Industries where we create legislation necessary to control what discharge into rivers. Hey, Mr. Industrious, please, you cannot pump that in. You're damaging our aquatic ecosystems, and it's getting soaked into the ground, and it's messing our ecosystems in general, our farming activities. So fines can be imposed into, for dumping into rivers, create buffer zone. Notice GIS coming in here, learners. Buffering, that you can't actually have any activities within certain radius from the river itself, because you will pollute or you'll cause a flood or there'll be massive runoff. So many sections are coming through, all right? Cultivation, where we talk about, and let me get my pen back. Cultivation, where we talk about farmers being educated on environmental and sustainable farming. Okay? Control floods through enlarging the river channels. You learn that about it, where the river channels are made wider so that there's more, can hold a greater volume of water. It reduces this. Some people spoke about, you can add on things like increasing the size of the levees, using man-made levees, which will reduce that. Deforestation was another problem, okay? And what happened here? We can plant trees and trap and decrease trap surface runoff, creating more infiltration, and also decrease erosion. So many of these answers we already worked out by looking at the source. We looked at the problem of industrialization, you understand, or industries, and we looked at solution. We looked at the problem of deforestation, and we looked at the solution. We looked at the problem of unsustainable farming, and we looked at the solution. And every little thing has come from, oh, we started off looking at this. So even with your high order question, you can use these little tips found on the resource and then elaborate on it. Learners, I just want to point one thing out again. Please, when you look at this, we call this, with these things in 12 lines, we call this the marker's memo. Please remember, any 12-mark question, all right? Any 12-mark question, and it says paragraph, you write in a paragraph. Please, learners, I know you may have heard that sometimes it gets marked, but why leave things to chance? Why leave things to chance, and what if it's not marked? So it says paragraph. Why don't we stick with it and write it in paragraphs? You were mentioning something, Abraham, that there was a question from one of my special learners there.
Yes.
Hey?
You ready for it?
Yes.
Okay, the question is from a mindsetter by the name of Reflector.
Yes.
So we need to reflect on this question. Reflector says, how do I identify a river capture or a parrot stream and captured stream?
River capture he's looking
Yes.
at. Is it Reflector?
Yes.
Reflector, I'm sorry that I don't have a diagram here, but I could create my own sketches, and I'm sure you'll be fine with that. All right? Before I go on to the next question, let's just help Reflector with his question. Now, first of all, again, it's the same 3 steps. Know the concept, know how to apply the concept, and apply the concept. So, river capture itself, river capture. Okay, the definition. When one river robs another river of its headwaters, I like to use the word robs, All right? Okay? Or you can also use the word when one river captures the headwaters of another river. Let's put this concept in place. Okay? When one river captures the headwaters of another river. Yo, I'm really impressed with my writing today, man. Learners, what do you think? You've seen me in shows before. My writing is getting better. I'm going to take pride. I want to take a photograph of this process of another. Okay, reflector, let's put this in a visual. Okay? Let's visualize two ways. Because that's your first question, what is river capture? All right? Let's take two ways. We got one system. All right? Let me just erase this. I want to maybe make it a bit different. All right? Let's create this. We've got one system where I've got something like this. I want you to visualize the Drakensberg down here. My favorite mountain. Drakensberg. Whoa. All right? Drakensberg. I'm just going to put Drak here. All right? Which is a watershed. Okay? And it's separating two river systems. One is your Tugela River. And one is your Vaal or the Orange River on that side. Now, you've picked up, we said when one river captures the headwaters of another river. There's two rivers here. Okay, you have the Tugela and you have the Vaal. There's one difference that we find between these two. And you've done that in the question before. You said on the eastern section, it's a steeper gradient. Also, the volume of water is greater because we have high rainfall. Okay, now, what is going to happen? Where would there be more erosion? On the Tugela side or the Vaal side? Obviously, you know the answer, reflector, that because it's a steeper gradient and because there's a greater volume of water, you will find that this side will experience more erosion. Can you visualize it being eroded here? All right? We call this headward or backward. Headward or backward erosion. All right? Headward or backward erosion. And it's eroding into that watershed. And it's getting in towards the Vaal side. Now, let's just use our eraser and visualize this area getting eroded. Now I want to just create my little stream again here. All right? Now the watershed has moved to this point. All right? So the river was originally here. This river was originally there. All right? Now, the watershed has moved towards the Vaal side. Now it's sitting down here. And the original position was here. What's going to happen to the headwaters of the Vaal River? In which side is it going to flow? Obviously, because the watershed has moved in this direction, this headwaters, there's a Tugela River flowing here, all right? So all these headwaters now flow into the Tugela River. The Tugela River has captured the headwaters of the Vaal River. Don't ask me what happened, but something moved here. Abraham, maybe there's something behind the screen I need to check. Right, I'm sure my mistake with technology. But I'm sure, Reflector, you're getting the idea that the headwaters were taken. So there's various factors. Number one, when one slope has a steeper gradient, okay, it will erode faster on that slope, move towards the one with the gentler gradient. When one slope has more rainfall, there'll be more erosion because there's rejuvenation, there's energy, and it'll move this way. When one slope has softer rock, it will move on to the other side, and that water that's left, it's going to capture it and bring it into that river, river capture. All right? Now, your second question, Abraham, I'm quite sure, was about captive stream and captured stream, etc. All right? Obviously, this part here would be the captured stream, and this would be the captor stream. But I think reflector is talking about the other type of river capture, where we get two streams flowing parallel, and then there's a watershed in between. I know these diagrams, reflector, can be very, very confusing. Okay, you don't visualize, you know, it's a cross-section of it, etc. But I want you to look at it this way, reflector, all right? I'm going to extend this page, not so much, I suppose. All right, I want you to see it like this, all right? Then I want to create a little stream coming in down here. Okay, and I want you to visualize this. Okay, there's the watershed here. We're going to call this River 1, River 2. Okay, and your watershed on this point. All right? Now, let's look at it, reflector. Okay, here we have a steeper gradient. I want to make this, maybe I should make it a bit more gentle here, eh? Something like that. All right, and there's a steeper gradient here. Okay, now what's going to happen? There's my tributary flowing here. Okay, it's flowing down here and going into this stream. Because this is steeper, what is going to do? It's actually going to cut into this watershed. There's going to be backward erosion down here, and it's cutting into that watershed. So if you look at it from the side here, or from a cross section, all right, this one here, okay, this is showing you a cross section of how it's cutting in, and as it keeps on cutting in, what's going to happen eventually? All right, it's going to cut and cut and cut, and let me use my eraser. Eventually, oh come on, where I've got it now. Eventually, it's going to take out all this part of the watershed, and what's going to happen now? When we do my pen again, all right, that piece is going to flow in here. Okay, that's your cross section. Let's put that into action on our diagram. There's my river here. There's my tributary here. Remember, there was a steeper gradient. And as this thing is flowing in and in and in, what's going to eventually happen? It's going to cut through the watershed. And as it cuts through the watershed, remember, it's steeper. It's going to flow in this direction. What happens to this water here? It gets captured by this tributary, and it's fed into that. This is the headwaters that has been captured and taken to River 1. Now what happens? This is the captor stream, because it actually captured the water. Captor. All right? There goes my writing again. Okay? Let me just scratch this off and write it neatly. C-A-P-T-O-R. This piece has been captured. So that's your captured. Captured stream. As the point of where it gets captured, it creates an elbow. I'm not trying to show my muscles, Abraham. I'm getting old. Okay, that's the elbow of capture. Okay, the elbow of capture. Not elbow, but elbow of capture. Okay? Of course, this river gets less water, so it starts to dry out down here. Okay? Use my little eraser again. Okay, I try again. So it takes it out there. Remember, this is going into this river. Okay, this starts to dry out. This river now gets smaller, and it doesn't suit its big banks, and we call that the misfit stream. I think, Abraham, I've answered the questions.
I think you have.
Okay. I hope you understand, Reflector, and I hope this question comes out at the end of the year, so you can knock it and get full marks. Eh?
On that note, it's time for us to take a net break.
You like your breaks, eh?
Yes, let's just do it like that.
Okay,
Once it is, let's get some after this. Hayi ke sibuyile into zikabawo ilixesha lethu basiqhubekeke ngenkqubo yethu ndiyathemba uba ixesha lenu nani nisalonwabele uba nifunde nathi. We have some questions for you, Dave, as we come back from the break.
I understand a lot of Zulu, etc., but I hope you're not swearing me.
No.
For sure.
Let's closer.
Yes, shoot, Abraham.
Let me shoot straight to it. Sipo says, where do they say any six except other reason?
Yeah. On this point here, you look at this question here. Lots of the paragraph questions says any six. Remember, you must give 6 points. Is it Sipo?
Yes, Sipo.
Sipo, remember you have to give 6 points. It's 2 marks each in your paragraph questions. So 6 points makes 12 marks. Now, because your questions, Sipo, are so open-ended, sometimes if we write a memo for some of these questions, it may take us a few pages. Just to give you an example here, Sipo, let's take this question again, all right? Suggest how we can take better care of our drainage basins. Okay, and let's take one of these questions, one of these answers here. All right, where was it? Yes, flood control through enlarging the river channels. Okay, that's one option, but I could give another one. Okay, I could say flood control by raising the height of the levees. I mean, that makes sense. Flood control by rechanneling the waters. If the river is coming down here, okay, I could create canals or channels away from there that will have less water. Now, these are just 2 answers, Sipo. Okay, there's many more that we could look at. Okay, prevent industrial development next to the area. Okay, I could then look at the diagram and say to stop residential areas near the river, to stop urban development next to the river. Now, all these answers make sense. So when we put this down here, Sipo, it's very, very important, all right, son, that we accept other reasonable answers, meaning that there are other answers besides this. So when the papers are being marked, we'll have to look at the other answers. But Sipo, one important point. When you're thinking out of the box, please explain fully. And your answer must be geographically sound. Okay? Those are 2 important things, Sipo, if you're accepting other answers from here. Okay? So we encourage thinking out of the box. Okay? But make sure it's clearly explained. All right? Abraham, was there another question?
Yes, from Ice Touch.
Ice touch.
Yes.
We've got the reflection. Now we've got the reflection of the ice. And we got Sipo drinking both, the ice and the reflection.
And Ice is giving that a touch.
He's giving it a touch. I like it. I like that name.
Ice Touch says, can you please help me on river discharge in a form of flow hydrograph?
Ah, beautiful. If Ice Touch, if you can be a little patient, what I got is, in fact, he's hit the nail on the head here. We've got one of our questions where we're dealing with a flow hydrograph. Okay, that will be coming in. So I'm going to judge the time and I'm going to say, whoa, I'm going to go on to the next question. Ice Touch. And what is going to happen is if I see I'm going too slow on that one, I'll go to the question on hydrographs and deal with that. Okay? All right. Let's look at question 3. Or maybe what I could do is let's go to the one on the flow hydrograph first. You know, Abraham, I might as well not take a chance. Because when I start talking, I don't stop sometimes and I'll never finish it. This was question 5 on flow hydrographs. All right. Many learners, I don't know, they scare for it. It's actually can be a very simple question. Now, obviously, the first thing when we look at a hydrograph a flow hydrograph is to know what does it do. What is a flow hydrograph? A flow hydrograph is actually measuring the discharge of a river or at a certain point over a given period of time. So this is the amount of water that's flowing. All right, it could be base flow, it could be surface flow. This is surface flow, by the way. So here it shows you the amount of time, the discharge. It's picked up slowly. There was rainfall down here. Can you see ice? Okay, there was rainfall, and as rainfall started flowing or started occurring, what happened? The ground started getting soaked in. There was a certain amount of infiltration, a certain amount of surface runoff. But as the rain continued, what happened? More and more water flowed on the surface, and what's happening now? We had a situation where there was more flowing, and we had the highest point when the rainfall occurred, where the river flowed, or the water flowed over the surface. Okay? Remember, it's over a period of time. It doesn't just happen now. We don't have this peak flow quickly. Okay? Depending. We can have it quicker at certain times, and it takes longer at certain times. Now, we notice rainfall happened. Okay? With this one, and the peak flow went up very quickly. Okay? You'll notice it this one. All right? Very quickly. Okay, let's look at this one. The rainfall happened. Okay? And the water was discharged on the surface. It's flowing. Okay? Now, look at this one. It's taken more time for it to reach the peak flow, the highest flow on the surface. It took more time. Yeah, it was quick. And simple stuff, ice. What do we notice written down here? Urban drainage basin. What do we notice written down here? Natural drainage basin. Okay, urban, what goes through our mind? Concrete surfaces, road, tar, steel. So how much water is soaking into the ground? Not much, isn't it? Okay, lots of surface runoff, less infiltration. So now what's going to happen? Over a short period of time, it will reach its peak flow. There'll be a lot of water flowing. Imagine concrete, lots of water flowing over the surface, less infiltration. Let's take a natural drainage basin. What do you visualize? Open surfaces, vegetation, soil. So what happens here? When it rains in this one, lots of water will infiltrate into the ground, and it'll take longer for it to reach its peak flow. That's the highest flow. So taking simple things like this helps you with your flow hydrograph. Okay? So we look at high peak flow because the urban area, over time, lower peak flow also, and a longer time taken to reach peak flow because it's open surfaces. All right? Now, other concept, lag time. Very simple. This diagram gives so much to you. And this was the supplementary paper. We look at the lag time here. And maybe I must get my pen moving again. And here, it's much shorter. What is lag time? Lag time is the time taken from peak rainfall to flood peak. It's shorter here. Why is it shorter here? Because it's concrete surfaces, not much soaks in. Peak flow is very quick. Do you understand? And therefore, peak flow comes in over a shorter period of time, shorter lag time. The time taken from peak rainfall to peak flow. Look at this one here, ice. Can you see this? It's much longer. All right? Why? Because when it's an open natural surface, what actually happens? It soaks into the ground. There's a certain amount of water flowing. And as soon as the ground starts soaking in more and the rain continues, then only will the level of the water on the surface rise, because it's open vegetation and soil. Therefore, the peak flow takes longer. Therefore, the time between the rainfall peak and the flood peak or peak flow, all right, is much greater. All right? So it's taking concepts of fluvial processes or geomorphology and applying it into one little thing. Don't just look at all those funny figures. Look at what I've showed you here. Okay, simply done, it actually assists you in answering the questions. Let's look at some of the questions, Ice. Okay, explain the term flow hydrograph. Okay, it's a discharge of a river over a period of time. And how we got it again? They're showing you discharge as it's flowing over a period of time. All right, let's look at the memo. A graph that shows river discharge over a period of time. Okay, please note, guys, I always tell learners, remember that this is a concept, eh? And that you can put it in your own words. Notice I didn't use the same words. But as long as it's got the same meaning, it is fine. All right? Look at the next one. Define the term lag time. Once again, you can work out lag time here. You can see the high block here. Okay? The high block here. All right, that's peak rainfall. Where else is it showing you? This is peak flow. This is time. So lag time is showing you that from there to there. So peak rainfall, peak flow over time. Okay? So it's between the difference between the time taken from peak rainfall to peak flow. Lag time. Getting all the answers from here, eh? All right? The time period that passes between peak rainfall and peak flow. I use slightly different language, but it's fine. It means the same thing. Okay? Now, look at this one on flow hydrographs. Explain or identify two differences observed between the hydrographs of urban drainage and natural drainage. Two differences observed. We look at the flow hydrograph. And I'm going to show you how simple this is. All I look at it, I need to find two differences. Let's go back again. Number one, the lag time is much shorter for the urban drainage basin, and it's longer for the natural drainage basin. We already worked that out. Next one. For the urban drainage basin, the peak flow is much quicker and higher, isn't it? There's more water flowing on the surface. Remember, it's concrete, it's flowing. All right? The peak flow takes longer, which is your lag time, and it's lower for the natural because water is soaking in. What I've done here is, and I think what you should also do is, look at your notes, and this is the important thing to all learners, I'm saying. Don't learn them in compartments, all right? Also, don't just rote learn. That is where I'm saying, and this is a good example, learners, of using resources when you are studying. Don't just take your notes and study them. Make sense on a resource, whether it's a flow hydrogram, whether it's an article, whether it's a diagram. Therefore, it will make your work much more easier to understand. And also, you're using different resources. So when it comes to the exams, you'll find that this is so simple that you thank your lucky stars that you have these resources because it leads you on to the answers, like in this case. You got your two differences already. Okay? And I'll show it to you here. All right. Urban drainage basin. Let me get my pen again. Urban drainage basin has a shorter lag time. All right. Hydrograph of urban drainage basin has a higher flood peak. Exactly what we worked out before we even looked at the answers. Hydrograph of a natural drainage basin has a longer lag time. All right. Hydrograph of a natural drainage basin has a lower flood peak. It's all visible here. Ice and other learners, right? It's all visible here. You made those deductions from there. Using your resources makes so much common sense, which leads you to better marks. All right? Let's answer, I think there's one more. What is the value of flood hydrographs for humans? Could be a low or a question, but you're visualizing stream discharge. Okay, that's what you're visualizing. That's what it measures, stream discharge. Okay, whether it's high, it's low, whether there's peak rainfall very quickly, or peak rainfall that takes a lot of time. What in fact this happens? Immediately you can play it in your minds, and you've done these things already in geomorphology or fluvial processes. Okay, you already know, hey, if there's a lot of discharge, what could it result in? Lots of water coming at one time. Obviously floods. You understand? Or the level of discharge is going down. You understand? There's less and less water passing this point. Our concern is about droughts. Or would I put a dam in an area where there's hardly any water to dam up? Where is the discharge quite strong? Where can I put my dam? You've already worked these little situations out in your mind. You understand? You've done them already in past sections of fluvial processes. It's now taking that information from different sections and putting it together. So geography is not out of this world, learners. It's actually applying your sources to the resources that you have here. And again, I know I'm mentioning it today quite a few times. It's not learning in parrot fashion. Just learn out. Take your memo and just do it that way. Let's look at some of the answers here. Eh? All right, there we are. Dams can be constructed. We worked this answer out already because we've done it in our notes. It's not something brand new. We just applied it. Dams can be constructed at the appropriate point where river discharge of maximum water conservation. Let's take another one. Useful for planning conditions. For planning in drought conditions. Hey, the hydrologist who's sitting and monitoring this, maybe sitting with a big picnic basket next to a scenic view, and he's checking the discharge of the river using certain instruments, and he feels the water is dropping. There could be a danger of drought conditions in the future. We can do planning. All right, makes it possible to predict peak flow during floods, when it's going to happen. Okay, makes it possible to predict whether the river will burst its banks. Whoa, there's a heavy rainfall. You understand? It's coming. We have a danger here. Maybe removing people from an area. Can you see that? It's of value to people. But you know this, learners. It's just applying it. All right, let's take the next question. Right? Future planning to reduce the impacts of extra floods experienced in the urban drainage basin and in the natural drainage basin. Okay, I think this question is a little on the side here where it's got a bit mixed up. Okay, what it's actually talking about here is that, and I'm going to rephrase this question, the urban area basin and the natural basin, there are differences in terms of the impacts with regards to floods, etc. Okay, I think the computer has been naughty here, okay, and messed up this question. So it talks about a difference between the impacts of a rural basin and a natural basin and an urban basin. And why is it different with regards to floods? Now, learners, here, I want to show you something here. All right? I was doing a little workshop, and very few learners actually who went through the supplementary paper realized that this memo that was found over the internet, etc., is different to the question. The question asked in terms of flow and floods, why is there a difference in terms of flow between urban drainage basins and natural basins? Okay, it wasn't between the different drainage basins, between urban and rural. And this memo showed you basically the difference between drainage basins. And therefore we need to be careful. Mistakes happen. Okay? And we just learn these things off like this without interpreting. That is why it's so important to take the questions, try and answer them first, and then look at the memos and say, hey, I think that is wrong on the memo. You understand? In this case, it was wrong. So I'm going to revisit this question.
Great advice. I like the advice that you're giving to the mindsetters. And I think on that very same note, let's take another break.
Hey, like it again.
I don't want that look. Otherwise, mindsetters, remember you can still tag yourself on the post that is on Facebook or share it and then give us your lucky number. Remember, Dave's number is number 6 and mine is number 8. So I don't know what's
Go
yours.
6. Go 6.
Go 6, hey?
Go 6.
Go 8. Go 8. Otherwise, we'll see you in Bawalenteng, so don't move. Yes, and Bingelela Futi Babugere Makaya. We have some good news that we're going to be telling you that we are about to stop the clock now, and currently we're on 54,005. So I'm gonna be fair since it's Heritage Day, Dave. You're only looking for one like. So after that question, I'll stop the clock. Hopefully it will be on number 6. Hey.
It is.
Yeah.
You know, and thank you for giving me. I'm just so pumped up. I'm enjoying this. I can actually see them through the camera here.
Really?
Those learners. There's lots of them, and they're enjoying it also.
All right. Well, right after that question, I'm stopping the clock, mindsetters.
It was gremlins, Abraham. It was gremlins. They messed up out our question. I found them at the back. I got rid of them.
Oh,
and then
thank
we have
you.
it perfectly done.
Thank
now.
you.
So let's get back to 5.5 learners. Again on this question. It's again, the question here clearly states, write a paragraph of 12 lines, approximately 12 lines, to explain the reasons for the difference in peak flow experience between urban drainage basin and natural drainage basin. And remember, learners, it's talking about why is the peak flow different, okay? And when we looked at it, I'll just pull it up quickly here. Remember, the peak flow for the urban area is quicker and higher, and for the natural vegetation, it takes longer and it's lower. Why is that the difference? So it's taking up your whole question that you looked at and summarizing it now. Okay? But remember, learners, what I told you? This one was not totally correct, this memo. Okay? But let's correct it with a few suggestions here, and I'll show you how easy it is. Okay? Number 1, what did we say? The urban area is made up of, I'm just going to write it in short, concrete and tar surface. Okay? Therefore, less infiltration, more runoff. Therefore, we know if it's more runoff, peak flow will be quicker. Can you see it, guys? Peak flow quicker. I'm just going to write a few points here because I know, learners, you know this one already. Okay, and then you do the opposite for the natural, where it's less vegetation, okay, and open surfaces, so therefore there's more infiltration and less surface runoff, okay? So concrete surface runoff, okay? Less infiltration, sorry, and more runoff. I'm just going to change this there. Infiltration. Now I'm messing up my writing again, learners, okay? And more runoff. On the natural vegetation or natural drainage basin, of course, it's made up of open surfaces. I'm just going to put it quickly here. Open surfaces. Therefore, more infiltration and less, okay, runoff. At the beginning, obviously, once the ground is saturated, therefore it will be coming peak flow. So your whole answer is going to be based on this. And provided you got 6 facts, okay, your answer is fine. All right? So be careful. No. Don't just go to the memos. Okay, we very rarely find this. But I made sure I wanted to leave the memo incorrect to tell you that you work the questions out first before you look at the memo. Don't be a con artist. Okay? Make sure you answer it first.
Tata my
All right.
chance. Well, Dave, I think I should stop my clock now before you move to that question.
It's 6 already, man. You're wasting time.
Well, unfortunately, it is 009. So 9 is our lucky
I think you
digit.
conned that.
I just missed it. It is 9. So to everyone that is luckily guessed 9, your name will go through to a draw and a winner will be announced on the last show, which is the one after this one from 4 until 5. So good luck, and we'll hold thumbs for you, Mansitters. Hope you are going to be the winner for that Len Extra awesome hamper.
Thank you, Avram.
Thank you.
All right, let's look at Let's look at another question, guys. And I'm sorry that we've got limited time, but let's take another question with its application. And we can see again how we can use the diagram and the information. This gives you a question on river profiles. Okay? River profiles. Obviously, again, learners, the examiner is directing you to a certain section. He will integrate other sections, or she will integrate. Okay, I don't want to sound sexist.
Yeah.
He or she will integrate other sections. All right, but the main thing is on river profiles. Look at this one, learners. There's so much information given to you here. Okay, it gives you a smooth concrete, concave profile, not concrete. Okay, and it gives you the stages of a river. Okay, I know we call it different. We can use torrent, valley, plain. Okay, doesn't matter. Whatever terminology is used, and as long as it's geographically correct, it's fine. It also gives you a cross or transverse profile. It shows you here in the upper course where it's steep and there's lots of vertical erosion. Okay, it's narrow and deep. Then it shows you it's going into the middle course where there's still a lot of vertical erosion, all right? And now there's some lateral. It's getting wider. Okay, and it's also showing you in the lower course where there's more lateral erosion and more deposition, and the Ware Valley is wide open. Okay, so much information. All right, look at it again. You also worked out that this is a longitudinal profile. Okay, this is a cross profile. So A showing you from there to there is longitudinal, B is showing you cross profile. All this information given to you there. Look at the question number 1, 3.1. Identify the type of profile labeled A. Now what we're doing here, learners, is we're not wasting time because as soon as we interpret this, we're going to go through the answers like that. Okay, you already know it's a longitudinal profile. I'm actually even wasting time opening it for you because you know it already. Look at the next question. What evidence suggests that A is a graded profile? You already worked it out. It's a smooth concave profile. And remember, we're preferring to A and not B. So, there we are. Has a smooth concave profile. Can you see how much information, learners? What forms the permanent base level of a river? And again, the answer is given to you here very quickly. Let's go up. Where's the last point that the river can go into? And it doesn't, you don't see the river anymore. Is the sea. And it's even shown here. All right, let's go to that. Obviously, it is the sea. Okay, let's look at one more here. Describe the difference between the shape of the valley at B and C. Okay, you've already worked it out. When you interpreted your diagram, and it doesn't hurt also, you know, for me to write on this little diagram doesn't help me, especially with my type of writing. You can put little notes on your diagram, learners, so that when you look at the diagram again, you look at the little points that you put there. I could put here narrow. Let me get my pen working again. Narrow. You understand? Okay. I could put vertical. Vertical erosion. Can you see my little notes? It helps, eh? I got that there, so quickly I look. Hey, And here I can see it's wider, more lateral erosion, more deposition. And there I'm ready for my answer. Describe the difference between the shape of the valley at B and C. Okay? And therefore you look at it here. V-shaped. Can you see it? More wide and opened at C. There you can see it clearly on this. So we don't have to be rocket scientists. You understand? I know most of you are, because you geography learners, you are rocket scientists. Abraham? Okay. But you don't have to be, it's not something out of this world, it's there. Use the information. Eh? Can you see it? Look at the next question. Give reasons for the difference in the shape. Again, your little short notes, etc., and your interpretation of the resource gave you the answers. You know already. Okay? Why it's different? Because you're having a vertical erosion at B and at C. You understand? It's flat area. Okay? There's more lateral erosion. There's more deposition occurring. Okay? Very simple to interpret. All right. Let's go to one more question. Okay. If you look at question 4, and I'm going to look at it down here.
Right. You know what? Because of time is just against us, unfortunately.
I'm sure. And my little mic stopped working here. So
you know why? It's because you don't have a watch, and I'm having a watch.
You understand? So I didn't listen to instructions, you see.
Well, but thank you very much, Dave. I really appreciate the lesson. So are the mindsets. Because of time, we have to end it there, unfortunately.
And I want to say thanks, Abraham.
Thank you.
I think you're brilliant, and I do believe you did do some geography.
Thank you.
And I do believe you're honest. You didn't take my number 6. You definitely got 9.
I'm sorry.
Learners, I'm so sorry. I enjoy it with you, and I hope you have enjoyed it also, that you've learned a lot. Remember, we may have not covered so many questions, but that's not a problem. The idea is the approach to answering the question.
Well said.
And
nothing beats that. And as
all the best. Focus, work hard, get an A in geography.
Well said, and on that said, mindset is that's where we have to end it today. Otherwise, do catch another lesson that is coming, which is history. We love you and peace. Hello and welcome to it, Mindset. This is Learn Extra Live on Spring School. Otherwise, it is also Heritage Day. So I just want to say this in my own language. I welcome you all into Sanbonani Dumelang Absheni. This is your show, Learn Extra. I'm joined by Dave. How are you, Dave?
I'm fine, Abraham.
Well, you look surprised. What's wrong?
No, I'm learning all the languages from you. Man.
Okay, but you can speak Sawubona.
Nah, Sawubona.
Unjani?
Nina ninjani.
Speedy that. You know what? I'm so proud of you. I'm so proud of you. Keep it like that. Otherwise, how's your holiday?
I think I must add in an Indian word to namaste. It's also a greeting.
It's also a greeting, yes. Yeah. I just don't know how to reply to that. It was going to be better if I was the one saying that. Yeah. But otherwise, how's your heritage and what are we doing?
I'm just excited to share knowledge with the learners, and I think that's part of Heritage Day.
Knowledge is power. Knowledge is power.
And maybe learn something from them also.
You are. Yeah. You are. Trust me. What are we doing?
Well, today we're looking at, hello learners. I hope you're ready for another live show of geography. Today we'll be looking at geomorphology, also known as fluvial processes and landforms. And we'll be looking at some past papers, the supplementary paper itself, and the various questions and the techniques that we're going to look at down there. I just want to tell the learners, and I hope learners, that you are actually balancing your time between your different subjects, which is very important. You know, not just your maths and science. So plan your timetable carefully. For instance, on Mondays, you can do science and geography. On Tuesdays, life science and geography. On Wednesdays, maths and geography. Am I doing geography too much?
Yeah,
But I
you
think they
like
get the idea. Please balance
Maybe
your time all the
history.
time. Okay?
I like that advisement. It is that every time you should always have a study timetable and follow it. Don't just draw it up and put it on the wall or on the fridge. Follow it. It's very much important. Kodwa-ke ngaphandle kokuchitha ixesha, let's get straight to it and let me tell the mindsetters what they need to know. To get in touch with us, you need to follow us on Twitter at LearnExtra, and secondly, like our Facebook page, which is having about 53,990 something learners. I'll be telling you more. We're close to 54,000, so get liking.
Us know the answers, but if you want to rectify whether we got the right answer, what do we do? Look at the word A down here. All right? And A shows you this point. Water is rising. And when water rises, it changes into water vapor. And of course, we get the concept of water moving up, evaporation. All right? But if you want to confirm, can you see water moving up? So that little resource gave us an idea of what the answer, and it confirms it. So here, when water changes to water vapor, it's evaporation. I'm impressed with my writing, Abra. Normally
nice.
I've got terrible writing. Eh? I think the learners know that by now. Okay, let's look at the next one. A place where two or more streams actually meet. A place where two or more streams meet, and it's giving us a little clue on the resource that it's B, in a drainage basin. Let's get back to the resource. Where two or more streams meet. Okay? So when we visualize it, the answer comes easier. So let's look at this. Obviously, where two or more streams meet is known as a confluence. Okay? All right? An area where the river originates. Many of you know the answer already, but let's look at the diagram. It shows you C. The river originates. And it's high up in the mountain there. Obviously, it is the source. Okay? All along the way here, learners, you actually see that the diagram is assisting you. All right? Let's look at the next one. The process whereby water seeps into the ground. And once again, learners, we have a visual as it's seeping into the ground. All right? And we know the concept will be infiltration.
The page is facebook.com/learnextra. Otherwise, you can also get your notes for the show for free on learnextra.co.za/spring school, all one word. But we have an exciting competition, and I know that a lot of you know about it, have seen it on Facebook, but let me tell you about it. You can win an awesome LearnExtra hamper, an awesome hamper from LearnExtra, by simply tagging yourself on the post that we have. We have a block of numbers from 0 to 9. So you choose a lucky number and tag yourself on your favorite number, or share the post and then write on that share your favorite number. For instance, Dave, what's your favorite number or your lucky number?
I'm going to give it to you. You won't take a lotto on it, eh? Because that's my number.
Yeah, what is it?
My number is 36.
Between 0 and 9.
Oh, 096.
6.
Yes.
Why 6?
I was born on the 6th.
You were born on the... Okay, I was born on the 8th. I'll take 8. Is it fine?
Yes,
so my
you
lucky
can.
number is 8. All you need to do is to tag yourself on that lucky number, your own, not mine, and also share on your wall and then write. You could win an awesome LearnExtra hamper. But lastly, you can join our geography group, which is Mindset Geography, which has also the notes, and you can also get other students who are doing the same subject, which is geography, helping you, and you help them. Otherwise, masingene go with that.
You're handing over to me for sure now.
Yes, sir.
Is your section finished?
Yes.
Abraham, you speak so well.
Thank you.
I'm sure you must have been doing geography. Eh? And I think map work was your favorite section. Because I can see you got direction. Now that's a good one.
That's a good one.
Okay, learners, let's go on. the fluvial processes and landforms, structural landforms, or also geomorphology. Before I go on to the section, many learners see this as a rote learning, parrot fashion section where they just take the notes and just study them and sort of try to regurgitate them in the exams. Now, learners, this section is different from that. Many of us, what do? We take the past paper and the memo and we sit with it together and try to look at the memo with the questions and say we're ready. I'm going to show you today that this section, actually, you can use the source material and get so much of the answers. So when you're studying this section also, it's important to look at the source material, to look at the visuals that you have and make sense of your questions in order to get the answers. And the section becomes so much easier. So we'll be looking at those various techniques. I know you've got the memo at home, but we'll be looking at techniques of how we use the source and how we get to the answers. Abraham, you're going to learn a lot.
Trust
And
me,
maybe
I'm
you're going to use it
open-minded.
at your
I'm ready to
university. Eh?
learn.
So that's what we're going to look at down here. All right, guys, let's get started. I'm going to take the first source. This is actually the supplementary paper 2013. And I'm going to take the first source that was used here. Okay? It says, refer to figure 1. And I must try and get my pen here. It says, refer to figure 1, which shows a drainage basin. Already, the examiner is giving you some direction towards what the questions are going to deal with. Immediately in your mind, the drainage basin concept should be playing around. Okay? An area drained by a river and its tributaries. Okay? A runoff system. And complete the statements below. Okay, and it's very quick for some of you that rote learn, is to just go into the questions and try and answer them. But let's look at this diagram. And I want to do this question together. I normally tell learners, interpret the diagram before you answer the question. And the rules still stick with that, because any source given to you has so many answers in them. So learners, but in this case, what I'm going to do now is I'm going to take the question and the diagram and show you the relevance of the resource. Okay? Now, it says a process, the first question, and of course you have to find the terminology for it. It says the process where water vapor changes into water. All right? The process, let me get back here. It's the process where water vapor changes into, sorry guys, I think my technology is messing up a bit there. When water changes into water vapor. Now, many of us, by the way, learners, I've been practicing my writing. I think it's definitely improving for this show. Okay? Last one, a highline area that separates two streams in the same drainage basin. Very important. The visual will show you here also. It's one stream, because with this question, learners, many people make a mistake between a watershed, all right, and an interfluve. Now, this is one stream. Okay, sorry, one stream or two streams of the same river system. It's not two different river systems. So it's important, this picture showed me already, and also it'll assist me from not making a mistake. Oh yes, it's one little river system here, all right, and there's two streams of the same river system. So it can't be a watershed, it's a interfluve, all right? So a highlying area separating two streams of the same river system is an interfluve. Okay? So quite a bit of answers. The visual helped us, and we were able to get quite a few answers even by just looking at this. So it's important. Again, fluvial processes, landforms, geomorphology is not just rote learning. You can pick up so much. And I'm going to show you on the next diagram of how much information we could actually pick up down here. All right? Let's go to the next one. It says, refer to figure 2, which illustrates a drainage basin. Again, the examiner actually draws your attention to the main concept being used in this question. And of course, that is your drainage basin. And immediately, if you got your visuals and you've been using visuals when you were studying, right, not just taking the questions and the memo and just trying to know this question and that's the memo, but working out that memo yourself and using resources, you will notice that you